On the 26th of December 2024, a large tailless aircraft lifted off from a runway in Chengdu, China, in broad daylight, escorted by a J-20 chase plane, and flew straight over a city of 20 million people. Phones were pointed at the sky. The videos were online within minutes, and within hours, defense analysts on the other side of the world were staring at grainy footage of something that was not supposed to exist yet. That same day, roughly 1,000 miles to the northeast, a second unfamiliar aircraft flew near Shenyang. Two completely different airframes, two different design bureaus, both flown on the same afternoon, both apparently sixth-generation designs. Nobody schedules something like that by accident. December 26th is Mao Zedong's birthday. Flying two experimental aircraft over populated cities in daylight with chase planes on a date loaded with symbolism is not a security failure. It is a message, and the message was aimed squarely at Washington. For 30 years, the United States has held one thing above all else in the air, not just better jets. Total superiority. The kind where an enemy pilot dies without ever seeing the aircraft that killed him. That advantage shaped every war plan, every alliance, every calculation about the Pacific. And in the space of a single afternoon, China told the world that the advantage might not be permanent. This is the story of how China went from copying obsolete Soviet designs to flying aircraft that American engineers are still arguing about on paper. It is a story about engines, about factories, about patience, and about a strategy that nobody in the West took seriously until it was already too late to stop. But to understand what flew over Chengdu, you first have to understand how far behind China used to be. Go back to the early 1990s. The Chinese Air Force was, by any honest measure, a museum. The backbone of the fleet was the J-6, which was a licensed copy of the Soviet MiG-19. That aircraft first flew in 1953. China was still building them into the 1980s and still flying them into the early 2000s. Think about that. While American pilots were flying F-15s with look-down, shoot-down radar and beyond visual range missiles, thousands of Chinese pilots were strapping into fighters designed when Stalin was alive. Then came 1991, the Gulf War. The Chinese military watched, on television, as the American air campaign dismantled the fourth largest army in the world in about 6 weeks. Iraq had Soviet equipment. Iraq had lots of it. It made no difference. Stealth aircraft flew over Baghdad and nobody could see them coming. Precision bombs went through specific windows of specific buildings. Iraqi air defenses were blind, deaf, and destroyed before they knew a war had started. For Chinese planners, that was the moment the ground shifted. Their entire doctrine had been built around mass. Huge numbers of soldiers, huge numbers of aircraft, absorbing an invasion and grinding it down. The Gulf War made mass look irrelevant. Quantity did not matter if the other side could see everything and you could see nothing. Then came 1996, the Taiwan Strait crisis. China conducted missile tests near Taiwan. The United States responded by sending 2 carrier battle groups into the region. China had no realistic way to threaten them, no way to track them, and no way to respond. Chinese officers have described that moment in remarkably blunt terms since. It was humiliating. And humiliation, in military planning, tends to be extremely productive. What followed was not a panic, it was a plan, and it stretched across 3 decades. The first step was buying time. China purchased Su-27 fighters from a collapsing Russia in the early 90s, then negotiated a license to build them domestically as the J-11. That gave Chinese factories something modern to learn from. Engineers took the airframes apart, studied the aerodynamics, the manufacturing tolerances, the materials, the way the Russians solved specific structural problems. Then they started building their own versions, then modifying them, then replacing the Russian systems with domestic ones. The Russians were furious. It did not matter. The knowledge had transferred. The second step was the harder one, building an actual aerospace industry. Not an assembly line, but the whole thing. Metallurgy, composites, radar physics, software, wind tunnels, test ranges, flight test engineers. And above all, universities producing thousands of aerospace graduates every single year, decade after decade, whether or not there was an immediate program for them to work on. That is the part that Western observers consistently underestimated. It is easy to laugh at a copied airframe. It is much harder to laugh at a country that has spent 30 years building the human infrastructure to design its own. By 2011, the results started showing. The J-20 made its first flight in January of that year, timed almost perfectly with a visit by the American Secretary of Defense. Again, the timing was not accidental. At the time, plenty of analysts dismissed it. The engines were Russian. The stealth shaping looked questionable from certain angles. The canards, those small forward wings, were supposedly bad for radar cross-section. The common assessment was that China had built something that looked like a fifth-generation fighter without actually being one. That assessment aged badly. By 2017, the J-20 was in operational service. By the early 2020s, China was producing them at a rate that surprised nearly everyone and had upgraded them with domestic WS-10C engines. Later versions moved to the WS-15, the engine the aircraft was actually designed around, which finally gave it the thrust it needed. Estimates now put the J-20 fleet somewhere between 200 and 300 aircraft, with production continuing. For context, the United States built exactly 187 F-22 Raptors and then shut the production line down in 2011. The tooling was put into storage. Restarting it now would cost tens of billions of dollars and take the better part of a decade. That decision, made when China's Air Force was still considered a joke, is one of the most consequential defense decisions of the century. But the J-20 was never the endpoint. It was the training exercise. So, what actually flew on the 26th of December 2024? Start with the Chengdu aircraft, unofficially designated the J-36 by observers, since China has released almost nothing official. It is large. Estimates from photo analysis put the wingspan somewhere around 20 meters and the length above 20 meters, which makes it substantially bigger than an F-22 and closer in size to a medium bomber. It has no vertical tails at all. None. And it appears to have 3 engines. Every one of those features tells you something about intent. The absence of vertical tails is the clearest signal. Vertical stabilizers are the single worst feature on a stealth aircraft. They are flat, upright surfaces that reflect radar energy brilliantly, especially from the side and from above. Every fifth-generation fighter still has them, angled outward to reduce the problem, because without them, an aircraft is extremely difficult to control. Removing them entirely is something only the B-2 and B-21 bombers have done, and those are subsonic aircraft that fly in straight lines. Building a tailless fighter that can maneuver requires flight control software good enough to keep an inherently unstable aircraft flying, using split ailerons, drag rudders, and thrust vectoring instead of a rudder. That software is genuinely hard. It is the kind of thing that takes years of test flights and a few crashes to get right. China flying one in public means the theoretical work is already done. 3 engines is the second signal. Fighters have 1 or 2. 3 means the designers needed something specific, possibly enormous power for high supersonic cruise, possibly enough electrical generation to run directed energy weapons and extremely powerful radar, possibly redundancy for very long-range missions over water, possibly all 3. What it definitely means is that this aircraft is not designed for short-range dogfighting over a border. It is designed to fly a very long way, carry a lot, and stay hidden while doing it. Then there is the size itself. Big airframes mean big internal fuel tanks and big internal weapons bays. Stealth aircraft cannot carry weapons or fuel externally without destroying their radar signature. So, range and payload are limited by internal volume. Full stop. The F-22 has a combat radius that is fine for Europe and inadequate for the Pacific. The Pacific is mostly water. Distances there are measured in thousands of kilometers, not hundreds. An aircraft designed to threaten targets far out into the Pacific has to be big. The Shenyang aircraft, informally called the J-50, is a different animal, smaller, also tailless, but with what appear to be swiveling wingtips for control. 2 engines. Analysts have suggested it may be intended for carrier operations, given Shenyang's history building China's naval fighters, and given certain features of the landing gear and airframe proportions. 2 different 6th-generation prototypes from 2 competing design bureaus flying in the same week. That is not a country hedging its bets. That is a country with enough engineering depth to run parallel programs and enough industrial capacity to potentially build both. And they were not finished. In 2025, more images emerged, additional test flights, a second J-36 prototype. The programs were clearly moving, but an airframe is only half the story. And the other half is where China's real problem has always been. Engines have been the persistent weakness of Chinese aviation for as long as Chinese aviation has existed. You can reverse engineer an airframe. You cannot reverse engineer a jet engine because the hard part is not the shape. The hard part is materials science. Inside a modern military turbofan, the turbine blades sit in gas flowing at temperatures well above the melting point of the metal they are made from. The only reason they do not liquefy is a combination of single crystal casting, exotic nickel-based superalloys, ceramic thermal barrier coatings, and microscopic cooling channels drilled through each blade so that a film of cooler air flows across the surface. Each blade is a small miracle of manufacturing, and an engine needs dozens of them, all identical, all reliable, for thousands of hours. Getting that right is not about stealing a blueprint. It is about running thousands of test cycles, blowing up engines, adjusting the alloy composition, adjusting the casting process, and doing it again. There are no shortcuts. It is why only a handful of countries on Earth can build a high-performance jet engine, and why the list has barely changed in 50 years. There is a reason the West guarded this technology so carefully. Export controls on turbine blade casting equipment, on specific alloy formulas, on the precision drilling machines that cut cooling holes, have been in place for decades. Those controls worked for a long time. They slowed China down by years. What they could not do was stop a country from eventually building its own equivalent equipment, and that is exactly what happened. For decades, China simply could not do it. Chinese fighters flew on Russian engines, and Russian engines with far shorter service lives than Western equivalents. Early domestic attempts had reliability problems severe enough that pilots reportedly did not trust them. Then, slowly, the picture changed. The WS-10 went from a program that was nearly canceled to the standard engine across most of China's fighter fleet. The WS-13 and WS-19 came along for lighter aircraft, and the WS-15, the engine intended for the J-20, entered service after years of delays that Western analysts had repeatedly pointed to as proof China would never close the gap. Now the reporting suggests China is working on adaptive cycle engines. These are engines that can change their own internal airflow depending on what the pilot needs. Open one path and you get high thrust for combat. Shift to another and you get fuel efficiency for cruising. It is the same concept the American NGAP program is pursuing, and it is one of the hardest problems in propulsion. Whether China has actually solved it is unknown, but the trajectory is what matters. Every single time observers said Chinese engine technology had hit a ceiling, the ceiling moved. Betting that it stops moving now requires a lot of faith and not much evidence. And propulsion is not even the part that scares planners the most. 6th generation is a marketing term as much as a technical one, but there is a rough consensus about what it means. Extreme stealth across all radar bands, not just the narrow ones 5th generation aircraft were optimized for. Very long range. Sensor fusion so complete that the pilot is not reading instruments but receiving a finished picture, and control of unmanned aircraft flying alongside. That last one is the actual revolution. Everything else is an improvement. This is a change in what an air force is. The concept goes by different names. The Americans call them collaborative combat aircraft. The general idea is the same everywhere. A manned fighter flies with several cheaper, semi-autonomous drones. Some carry extra missiles, some carry sensors, some carry jammers. Some exist purely to fly ahead and get shot at, revealing where the enemy air defenses are by dying. That last point matters more than it sounds. The most dangerous moment in modern air combat is the moment you turn on your radar, because the enemy immediately knows where you are. If a drone can do the searching while the manned aircraft stays silent and hidden, the entire tactical math changes. The pilot becomes a manager of a formation rather than a shooter. It also changes the economics of attrition. Losing a fifth-generation fighter means losing an aircraft worth well over $100 million and, far worse, a pilot who took a decade and enormous expense to train. Losing a drone means losing hardware. In a long conflict, the side that can afford to lose things wins. China has been extremely visible about this. At the September 2025 military parade in Beijing, alongside the missiles and the marching formations, they rolled out unmanned combat aircraft, loyal wingman designs, and underwater drones. Chinese defense firms have been showing drone concepts at Zhuhai air shows for years. The GJ-11 Sharp Sword, a flying wing stealth drone, has been publicly displayed and appears intended to operate alongside manned aircraft. The point of a parade is not military, it is political. Displaying an entire ecosystem of unmanned systems tells domestic audiences the country is modern and tells foreign audiences the investment is real and ongoing. Which raises the obvious question: what has the United States been doing? The honest answer is that America started earlier, then spent years struggling to decide what it actually wanted. The Next Generation Air Dominance program began quietly. In 2020, an Air Force official revealed that a full-scale demonstrator had already flown, and had flown some time before the announcement. That was, at the time, a genuine shock. The United States had built and flown a sixth-generation prototype in near-total secrecy. Then, the program stalled. Not technically, financially and philosophically. Estimated costs reached figures around $300 million per aircraft, which is roughly triple an F-35. Senior officials began openly questioning whether the concept made sense at all in an era of long-range missiles and cheap drones. In 2024, the program was effectively paused for review. In March 2025, it restarted. Boeing won the contract for what is now designated the F-47. Renderings were released showing a tailless design with canards, which immediately triggered arguments among analysts about whether the images were accurate or deliberately misleading. The Navy's parallel program, F/A-XX, has moved more slowly and has faced its own budget fights. So the picture is not one of American stagnation. It is one of American deliberation, running into a competitor that appears less interested in deliberating. And that difference in tempo is the real story, because it comes down to something much less glamorous than stealth shaping. It comes down to factories. China builds things at a scale that is genuinely difficult to describe. It produces more than half the world's steel. It launches commercial ships at a rate that is estimated to be over 200 times American output by tonnage. It dominates global production of rare earth elements, which are essential for the magnets, motors, lasers, and precision components inside modern aircraft. It has the world's largest manufacturing base by a very wide margin, and much of that base can be redirected. Military power is downstream of industrial power. That has been true since the American Civil War, and it was true in both world wars, where the decisive factor was not the quality of any single weapon but how many could be produced and how quickly losses could be replaced. There is a second-order effect that rarely gets mentioned. A country that builds ships, trains, wind turbines, and consumer electronics at enormous scale also builds the machine tools, the welders, the composite technicians, and the quality control systems that military aviation depends on. Those skills do not sit in a separate box marked defense. They move between industries. When a nation loses its commercial manufacturing base, it quietly loses the defense one too, just more slowly and less visibly. Right now, China can build airframes faster than the United States can. Chinese J-20 production has been estimated at around 100 aircraft per year at points, which is a genuinely remarkable figure for a stealth fighter. Meanwhile, the American defense industrial base has consolidated down to a handful of prime contractors, supply chains have thinned, skilled workers have aged out, and restarting closed production lines has proven expensive and slow. None of this means China wins anything. It means the assumption that America can simply outproduce a rival in a crisis, which shaped planning for decades, is no longer safe. There is a second Chinese advantage that gets discussed less often: geography. If a conflict happens over Taiwan or in the South China Sea, Chinese aircraft take off from Chinese soil, minutes from the fight, from hardened bases with layered air defense behind them. American aircraft take off from a small number of bases in Japan, Guam, or from carrier decks. Guam is roughly 3,000 kilometers from Taiwan. That distance has to be crossed by tankers, and tankers are large, slow, and impossible to hide. A stealth fighter with a long range and an enemy strategy built around killing tankers can neutralize an air force without ever fighting its fighters. That is precisely why the Chinese aircraft that flew in December 2024 appear to be so large. They are not built to win dogfights. They are built to reach far out over the Pacific and threaten the support aircraft that make American air power possible at that distance. Now, a necessary dose of skepticism, because the hype around this subject is enormous and mostly unearned. A prototype is not a fighter. Between the aircraft that flew over Chengdu and an operational squadron sits an enormous amount of work: flight envelope expansion, weapons integration, sensor calibration, software that has to be debugged over thousands of flight hours, maintenance procedures, pilot training pipelines, spare parts logistics. The F-22 first flew in 1997 and was not declared operationally capable until 2005. The F-35 took even longer and had a development history that generated its own genre of critical journalism. It is also worth remembering how often confident aircraft predictions have collapsed. The Soviet Union flew impressive prototypes throughout the 80s that never entered meaningful service because the money ran out. Several European programs produced beautiful demonstrators and nothing else. A first flight generates headlines. Sustained production, funding, and political commitment over 15 years generate air forces, and only one of those things happened in Chengdu in December. China's timeline will not be shorter than that just because the videos looked impressive. Realistically, these aircraft will not be in meaningful operational service until sometime in the 2030s. There are also things nobody outside China knows. What is the actual radar cross-section? What are the engines really capable of? Does the sensor fusion work? Or does it produce a confused picture that overloads the pilot? Are the materials durable in real operating conditions, or do the coatings degrade after a few dozen flights? What is the reliability rate? And there is the human factor. Aircraft do not fight. Pilots and organizations do. The American military has been fighting continuously for over 20 years. Its training system, its maintenance culture, its combat experience, and its network of allied air forces represent institutional knowledge that cannot be manufactured. China's Air Force has not fought a real air war since the 1950s. That gap is real, and it is not something a new airframe fixes. But there is a counter-argument, and it is uncomfortable. Combat experience against insurgents with no air force is not necessarily preparation for a peer conflict. And China has spent decades studying exactly how the American military fights, because that is the only opponent it has ever planned for. Meanwhile, China's exercises around Taiwan have grown steadily larger and more complex, giving its pilots repeated practice at coordinating large formations over water. So what actually changes because of this? The first thing is the end of an assumption. For 30 years, American air superiority was treated as a constant. It was the foundation under every plan. Ground forces moved, assuming nothing would bomb them. Ships operated assuming an umbrella above them. Allies made political commitments assuming the umbrella would still be there in a crisis. If that assumption becomes a question rather than a fact, everything above it has to be rechecked. The second thing is the deterrence calculation. Deterrence is psychological. It works when a potential aggressor believes an action will fail or cost more than it is worth. It does not require anyone to actually be stronger. It only requires belief. If Chinese leadership becomes convinced that its air force could contest the skies over Taiwan long enough to matter, the calculus shifts, not necessarily toward war, possibly toward more aggressive coercion, more pressure, more confidence in a standoff. The third thing is the arms race that is now clearly underway. Japan is developing a next-generation fighter with Britain and Italy through the GCAP program. South Korea is fielding the KF-21. India is developing the AMCA. France, Germany, and Spain are working on FCAS. When they can agree on anything. Australia is buying into long-range strike. Every capable country in the region is spending more, and the December 2024 flights accelerated all of it. The fourth thing, and maybe the most important, is a change in how technological leadership is understood. The old model assumed China would always be a few years behind, copying rather than inventing. That model is dead. Two independently designed sixth-generation prototypes from two competing bureaus is not copying. Whatever else is true, the innovation gap has closed far more than most people expected. There is one more thing worth sitting with. These aircraft may already be obsolete as a concept before they enter service, and China may know it. The most successful air defense weapon of the last few years has not been a fighter. It has been cheap drones, dense missile networks, and electronic warfare. Wars in Ukraine and the Middle East have shown that $100 million platforms can be threatened by systems costing a tiny fraction of that. There is a serious argument, made by serious people inside the American defense establishment, that manned fighters are a dying category and that the future belongs to swarms of expendable autonomous systems. If that is true, then both China and the United States are building extremely expensive answers to a question that is changing shape. And the country that figures out the drone problem first will matter more than the country with the prettiest airframe. But notice something. China is building both. Manned sixth-generation fighters and a very large unmanned ecosystem simultaneously. That is not a bet. That is a refusal to bet. Step back and look at the whole arc. In 1996, China watched two American carriers sail into its neighborhood and could do nothing. In 2011, it flew a fifth-generation prototype that Western analysts dismissed as a mock-up. By 2017, that aircraft was operational. By the mid-2020s, it was in service in numbers exceeding the entire F-22 fleet. In December 2024, two sixth-generation designs flew in the same week. That is 30 years, 3 decades of sustained investment, of building universities and factories and test facilities, of absorbing criticism and continuing anyway, of programs that took 15 years to produce results, while outsiders declared them failures. The lesson is not really about aircraft. It is about what a country can do when it decides on a goal and then does not change its mind for a generation. Democracies rotate leadership every few years, and priorities rotate with them. Programs get canceled, restarted, redesigned, and renamed. That process has real advantages, including the ability to correct expensive mistakes. But it is slower. The aircraft that flew over Chengdu was not the achievement. It was the receipt. Whether it will change everything depends entirely on things nobody can see yet. Whether the engines hold up, whether the software works, whether the pilots are good. Whether the whole category matters in 10 years, prototypes have failed before, programs have collapsed before, confident predictions about future air combat have a long history of being wrong. But the era where anyone could laugh at Chinese aviation ended some time ago, and most people simply did not notice when it happened. The videos from December 26th were not the moment the balance shifted. They were the moment the shift became impossible to ignore. Somewhere in Chengdu right now, engineers are reviewing flight test data from an aircraft the rest of the world has only seen in shaky phone footage. Somewhere in the United States, engineers are doing the same thing with an aircraft the public has only seen in a rendering. Neither side knows exactly what the other has. Both are moving as fast as they can. That is where things stand. Not with a war, not with a crisis, but with two countries building machines they hope never get used, each one convinced that the only way to avoid a fight is to make the other side certain they would lose it. Whether that logic holds is the question that will define the next 20 years. If you found this breakdown useful, hit subscribe. Every week we go deep on the technology, industry, and strategy shaping China and the wider world, the stuff that gets one headline and then disappears. There are more videos on the screen right now if you want to keep going. And here is the question I want your take on. Do you think manned fighter jets still have a future at all, or is the entire concept about to be replaced by drones? Let me know in the comments.